Okay, so continuing with section 7.2, let's consider, once again, triangle ABC. Triangle ABC, not a right triangle. Okay, so let's say A, B, and C. With opposite sides, little a, little b, and little c. And altitude or height, h. So we know that the area of a triangle is 1/2 the base times the height. So let me color code these. Base. Okay, let's call this one blue or yellow maybe. Okay, so let's consider, let's have A be green, C be yellow, and B be purple. Oops, nope. Okay, so what do I know about, change this to green. Let's consider, what color shall I use? Orange. Let's consider sine of angle A. Sine of angle A. Well, looking at the left-hand triangle, right triangle, do you agree it's opposite side H over hypotenuse to the left-hand triangle, which is little c? So if I take and I multiply this equation through by little c, do you agree that what I get then is that little h, height, is actually equal to c times sine of angle A. But I could do the same thing. So let me move this to the left. I'm going to need a bit more room. I could do the same thing. Where do I want to put this? For angle C. That is, I could say sine of angle C well, if I look now at the right triangle, once again opposite to angle C, the opposite side is height H, and the hypotenuse to the right triangle is A. So now let's once again multiply through by A to get rid of the denominator. So this gives us that the height H will be equal to little a times sine of angle C. Okay. So coming back to area, area is 1/2 the base, B. Now the height, I can use either one of these guys. I could use height C sine A or A sine C. It doesn't really matter. Let's use the second one, shall we? So times A sine of C. Okay, so theorem. So given side angle side, do it that way, side angle side. So the area of triangle ABC. Oops, why did that not work? Triangle ABC with opposite sides. Opposite sides, little a, little b, and little c respectively. Is given by any of, number 1, area is 1/2 AB sine of angle C, which is what we derived above. Number 2, the area could be 1/2 BC sine of angle A. Or number 3, the area could be 1/2 AC sine of angle B. Okay, so it doesn't really matter which sides we use, just as long as the angle is the one that is in between the two sides, hence side, angle, side. So we notice here's A and B, and C is the angle between them, so side, angle, side. Okay, so let's put this to good use. So for example, so let's find the area of triangle ABC. So find the area of triangles ABC given. So number 1, let's say we have that little a has measure 3, little b has measure 8, and the measure of angle C is 30 degrees. So I've got A, B, and C, the angle between. So I claim the area is going to be 1/2 A, B, B times sine of angle C. Okay, so the area will be 1/2 times 3 times 8 times sine of 30 degrees. And of course, 2 goes into 8 4 times. So we have that the area will be 3 times 4 is 12. And sine of 30 degrees is 1/2. So the area of this triangle is 6. Okay, let's do another one. So subscript number 2. Let's say we're given the measure of side B is 14. The measure of side C is 6. And the measure of angle A is 60 degrees. Okay, so in this case we have area will be 1/2. Let's do B in yellow. Let's do C in orange. And then we'll do angle A in purple. Sine of angle A. Okay, so the area will be 1/2. B is 14. 14. C is 6. And then sine of 60 degrees. So we have that the area will be, well, I know that 2 goes into 14 7 times. Okay, so 7 times 6 is what, 42? And a sine of 60 degrees is the square root of 3 over 2. So now 2 goes into 42 21 times. So we get that the area for this triangle is 21 times the square root of 3. Okay, so there we are. I'll see you in section 7.3.